Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 11, Lesson 2 on the standard deviation of a data set. Now in our last lesson we talked about the purpose of statistics and how its purpose is really to answer statistical questions, questions where variability is involved. Now one of the main things that we're concerned about in statistics is trying to measure how much variability there is in a data set. And that's exactly what the standard deviation is going to help us do. But first, let's jump into some review material. All right, variability in a data set. Statistics contains tools to answer questions that involve variability. We want to be able to quantify how much variability exists. And when we say quantify, what we mean is like assign a number to it, right? Two measures that we've already seen for variation are the range, right? And that's like the overall variability, the max minus the min, and the interquartile range. And that's really how wide the middle 50% of the data is. So let's get into exercise 1 and review a little bit on that. A marketing company is trying to determine if there is a difference in the age of people who drink two different sodas. They take a random sample of 15 people who like each soda and record their ages. The ages for both sodas are shown below. All right, so we've got these two data sets, right? Soda A, soda B, right? We've got the ages of people who like that soda, the ages of people that like that soda, right? And again, the implication of this sort of study, right, is trying to figure out if one soda is preferred by older people versus younger people, et cetera, et cetera. All right? So let's take a look at letter A. Use your calculator to help find the 5-number summary for both samples. All right, so by the way, let's just talk about this for a second, right? The 5-number summary is the minimum and the maximum and also the median, but also the first quartile and the third quartile. And keep in mind that what the first quartile, third quartile, and median do is they're like knives that slice up the data set into quarters, right? You got the first quarter of the data between the minimum and the first quartile, the second quarter of the data that falls between the first quartile and the median, the third quarter of the data between the median and the third quartile, and the last quarter of the data between the third quartile and the maximum. So let's enter this data into our calculators. Now again, we mentioned this in our last lesson. How you enter data in a graphing calculator is very, very specific to the calculator itself. I'm using the TI Inspire, which I absolutely love, because what it's got is it's got an option to add lists and spreadsheets. So if I want to add this data into my TI Inspire calculator, I open up one of those lists/spreadsheets and I start entering the data. And I can literally enter soda A into letter A, I can enter soda B into letter B, and then we can do those statistics and find all of those various measures, right? Min, max, first quartile, third quartile, etc. All right. So what I'd like you to do right now is pause the video, find your lists in your calculator, and enter those two sets of data in, list 1, list 2, or column A, column B. However your calculator works. Of course, if you're using the TI Inspire, that should be pretty easy for you because you're going to be following along with me. If not, take a moment to figure that out. Pause the video now. All right, now for me, what's great is I've actually pre-stored this. So I'm gonna go in and I'm gonna open up my document that actually has all of this already in it. All right, so let's, there it is. One thing I like doing when I put my data into the TI Inspire is I actually like labeling my two data sets or even my one data set. That's very easy to do by just kind of going all the way up to wherever the name is, hitting enter. You can type a name in. It's just kind of convenient to like be able to then know what you're talking about. All right, so now let's do the stats, okay? To do statistics, once we have data in the TI Inspire, we hit the menu command, which is often the case no matter what we're doing, and we're gonna choose one of these things. Specifically, we're gonna choose the statistics option, all right? And now we want our stat calculations, that makes sense, okay? We want one variable statistics. Now, I know that sounds strange because we've got these two lists of data, but it really is only one variable statistics, okay? So I'm going to hit that. And here's the key, right? Now it says number of lists. So I'm going to just hit up arrow there to set it to 2 lists because I've got 2 lists, and I'm going to hit OK. My X1 list I can hit over and I'm going to say, that's soda A. My X2 list is soda B, all right? And my first results, I'm not going to worry about that. I'm just going to hit OK, right? And what it's going to do is it's going to say, okay, well, there's data in soda A, there's data in soda B, right? Then it's going to list sort of what statistics we have over here, and then it's going to actually start kind of giving them to me over here. All right, so what I'm looking for is I'm looking for things like min, max, etc. For the first soda. Here's all that stuff. Let me get it all the way in. Literally, my 5-number summary for soda A is right here. Minimum value 16, Q1 18, median 25, Q3 36, and maximum 44. All right, so very, very easy to do that. I'm going to put this on handheld only so I can see this and enter it onto my sheet. Full screen. Where's my pen? There it is. All right, my minimum value is 16. My maximum value is 44. My first quartile value is 18. Third quartile value is 36. And maximum value is 44. Again, let me just exit this just for a second. Put it on the big one as well. Now, to get to that second column of data, all I have to do is hit my right arrow. Hopefully hit my right arrow. There it is. And I get my second row of data right there. So here are my first set of statistics. Here's my second set of statistics. Again, my minimum value for soda B is 18. My first quartile is 19. My median is 23. My third quartile is 27. And my max is 30. Easy, right? We're letting the calculator do all of this kind of random statistics that we would have done back in middle school by hand because we just don't need to do it by hand anymore. All right, first quartile is 19, third quartile is 27, and median is 23.
Soda A median. Soda A median.
Soda A median, uh-oh. Oh, yeah, I just totally wrote that in wrong. Thank you, Joey. All right, soda A median is not 44, that's the maximum. The median there is 25. Let me just check these over. 16, 18, 36, great, 44, excellent. All right, so let me put that back on keypad and we'll just reduce that, and here we've got our statistics. All right, now, little review from a previous course, right? Now that we've got our 5-number summary, we can start to draw what are called box plots. So let's take a look at letter B. All right. Draw a box plot for the two data sets shown, the two data sets below. All right, so what I'm going to do is I'm going to take these things and I'm going to draw box plots. Let's review how to do that for soda A, and then you can do it also for soda B. So what I'm going to do is I'm going to put little vertical lines above each one of these numbers. So for the minimum, I'm going to put a little vertical line above 16. Then for the first quartile, a little vertical line above 18. Then for the median, a little vertical line above 25. For the third quartile, a little vertical line above 36. And for the maximum, a little vertical line around above 44. Now, this is called a box plot because what then happens is we then draw a box around the middle 50% of the data, and we then extend what used to be called whiskers out to the maximum and the minimum. And what this does is it gives you a representation with a picture for how the data in soda A, sample for soda A, was distributed. All right, now what I'm going to do is I'm going to label this soda A, right, so that I can know which one's which. What I'd like you to do now is pause the video, draw the box plot for soda B, and it's a little bit tricky, but I'd like you to draw it right above the one for soda A. All right, so here we have a minimum of 18. We have a first quartile value of 19, so right afterwards. Then we have a median of 23. Then we have a third quartile of 27. And finally, we have a maximum of 30, right? So this is a much smaller box plot, or at least more narrow. And let's label that soda B. All right? And again, what's really nice about this is it gives us an immediate picture that can help us compare visually how the two sodas' datas compare. All right? So let's keep going. Okay, letter C. What is the interquartile range for each sample? All right, now remember, the interquartile range has a very simple definition. It's the third quartile minus the first quartile. More importantly, though, it is literally the width of the box up here, right? It tells you how widely spread out the middle half of the data is. We oftentimes think about those as typical values. So what I'd like you to do right now is pause the video and calculate those two. Make sure you label which one's soda A and which one's soda B, and then we'll discuss them. Take a moment. All right, well, for soda A, we can see the third quartile is at 36 and the first quartile is 18. So for soda A, typically the interquartile range is abbreviated as IQR because it's a little bit annoying otherwise. 36 minus 18 gives us 18. Okay. And for soda B, all right, we can see we've got 27 minus 19. Which is going to be 8. And these really do have units, 8 years and 18 years, right? So in other words, the people who preferred soda A, the middle 50%, the range in their ages was 18 years, and the people who preferred soda B, the range in the typical values there is only 8 years. All right, so now let's take a look at letter D. Make a statement comparing the ages of people who prefer each soda. Include both a comparison of the medians of the groups and the variability within each group. All right, so again, it's kind of like going back to our statistical question, right? It's sort of like, all right, what are the ages of people who like these two sodas, right? Well, let's go back up and take a look at those medians once again, right? For soda A, the median, right, is 25 years. Soda B, the median is 23 years. So the median age is really quite close, right? So the two sodas had very close median ages that only differed, right, by 2 years. However, there was a much greater variation in the ages of those who liked soda A with its IQR being how many years more? 10 years more. Than soda B. By the way, if you think to yourself right now, man, there's a lot of writing in statistics, you are correct, right? And that occurs because you're analyzing and you're discussing, right? Probably more than any other field in math, statistics requires you to look at the numerical answers that you get for these statistics and interpret them, and that interpretation takes some writing. But it's pretty impressive, right? I mean, we can say that there isn't really much of a difference in sort of the average or the median age of people who like these two sodas. And yet, there's a much greater variation in the ages of people who like soda A than who like soda B, based on either the IQR, which is different by 10 years, or even the range, right? The overall range of soda A goes from 16 years to 44 years versus for soda B only going from 18 years up to 30 years, right? So the central number, that's roughly the same, but the variation is much greater in soda A. And maybe that tells us something, right? Maybe that tells us that we should market soda A to a much greater range of ages, but we should really target our marketing of soda B to this much more narrow age range. Okay, let's keep talking. And now let's get into the standard deviation, which is one of the most important statistical measures in all of statistics. Interquartile range is an excellent measure of the variation in a data set. It really is very good, and we'll keep working with it throughout this unit. Another tool that has been developed is known as the standard deviation of a data set. Now, there's a very complicated mathematical formula for calculating it, all right, which you will learn undoubtedly in a later math class, possibly Algebra 2, or possibly a statistics course when you go to college, okay? But for now, we're going to let the calculator do its own thing. Let's take a look at exercise number 2. Given the two samples we have been working with, use your calculator to find the sample standard deviation for both data sets. Typically in the calculator, that's represented by the small letter s, sometimes with a subscript with an x on it, sometimes not. It says round each answer to the nearest tenth. All right, let's talk about this. Now, the formula for standard deviation, which we're not going to even put up on the board, but that formula involves a square root. All right, and we just got done with a few units where square roots popped up quite a bit, and they're messy, right? Because they give irrational answers. So oftentimes, not always, but oftentimes the standard deviation is a messy, messy number. And let's go back and take a look at it. Now, we've already run the statistics on this package. We just have to find where the standard deviation is. So I'm just going to kind of pop back up, and there it is, right? So here we see it, that little s of x right there. Here's the standard deviation for soda A. Here's the standard deviation for soda B. Remember, we're supposed to round both of these to the nearest tenth. So for soda A, it's 9.09212, etc. So that's going to round to 9.1. For soda B, it's 4.08481, etc. So that's going to actually round to 4.1. So we have this 9.1 and 4.1. All right, 9.1 and 4.1, maybe. Put that decimal place down here where it belongs. Bad decimal point, bad. Okay, so one thing you just have to be able to do, honestly, with standard deviation is get your calculator to calculate it for you, right? And that's about putting that data set into your calculator, or data sets as the case is here, right? Running the proper stat package, and then finding that little s, all right? Now, your teachers might also mention that there's something called the population standard deviation. But the vast majority of times when we work with statistics, and I mean like almost always, we are going to be working with samples. So we are going to be going for that sample standard deviation, that little s, okay? So let's take a look now at exercise number 3. How do the values of the standard deviation you found in exercise 2 compare to the values of the interquartile ranges you found in exercise 1C? All right, well, let's write them down here, right? For soda A, our standard deviation was 9.1, and for soda B, our standard deviation was 4.1. All right, so I bet if you look at this number compared to this one, and this number compared to this one, you might see something that is pretty obvious. May not be pretty obvious, but take a look, pause the video, and see if you can make a statement about how standard deviation somewhat compares to IQR. All right, well, hopefully it occurs to you that half of 18 is 9 and half of 8 is 4. In fact, the standard deviation is often close to half of the IQR. Now, don't get me wrong, I don't expect it to be half of the IQR, okay? If that was the case, we'd get the IQR and we'd divide it by 2. Do you know what I mean? And that's how that wouldn't be a complicated formula, right? Oftentimes the standard deviation is actually just a little bit more than half of the IQR, and you see that actually show up in both of these situations, okay? Now, so far we really haven't talked much, though, about what in the world standard deviation is. So let's talk about the meaning of standard deviation. Standard deviation measures the variability within a data set and roughly gives us an average distance that a data point is away from the mean of a data set, okay? So again, if I go back to just these two, right, the way I could interpret this for, let's say, soda A, is that, I've got some mean, which we didn't calculate, right? We only had the median. But what this number tells me is that any given one of these points, on average, is about 9 units away from the mean. Any one of these points, on average, is roughly about 4 units away from the mean. Now, obviously, some of them are closer to the mean, some of them are farther away from the mean, but on average, they're about 4 units away from the mean and 9 units away from the mean. And therefore, it kind of makes sense that it's half of the IQR, because the IQR is the spread of that middle 50%. So it kind of makes sense that that might be the average distance. Now let's take a look at exercise number 4. According to your answers from exercise number 2, in which of the two data sets is there a greater diversity in ages? Well, that's exactly what standard deviation does, right? There's a greater diversity for soda A because its standard deviation is larger. And that's what we use it for. Standard deviation is used very similar to IQR to basically say, hey, look, there is more variation or diversity or difference in the data in this data set than there is in this one, right? I mean, soda A's average distance away from the mean was over twice as much as soda B, right? Soda A had a standard deviation of 9.1, soda B had a standard deviation of 4.1, and that tells us right away that there is way more variation in the data for soda A than there was for soda B. All right, now most of the data in a data set will fall within one standard deviation of the mean, and we're gonna talk a lot about this kind of phrasing, the amount of data that falls within one standard deviation of the mean. This simply means that typically more than 50% of all the data values fall closer than one standard deviation to the mean, all right? A little bit more than 50%. And we'll talk about how much more in the next lesson, but let's take a look at this question immediately in exercise number 5. Find the mean of each data set, finally, round to the nearest tenth. Then construct an interval of ages for both data sets that represent all values within one standard deviation of the mean. Okay, we're going to be doing this quite a bit in the next few lessons, so let's sort of take our time with this. Okay, let's make 2 columns. One for soda A, hopefully one for soda A, and one for soda B. Okay, first thing I want our means, all right? Remember, we symbolize those with a little x and a bar over them. Oftentimes we say x bar. Now again, because we've already worked out the statistics on our calculator, all we have to do is just find those 2 means, and there they are, right? So for x bar, right, for soda A, the mean was 26.7, rounded to the nearest tenth. And for soda B, this one came out very nice, exactly 23.4. So 26.7 and 23.4. All right. Now let me go back to full screen. We also knew that the standard deviation was 9.1 for soda A, and the standard deviation for soda B was 4.1. Now, I want an interval that represents all values within one standard deviation of the mean. All right, in other words, I want to know all the values that are closer than 9.1 units to the mean in this case and 4.1 units to the mean in that case. So what I'm going to do is I'm in both cases going to take the standard deviation and I'm going to subtract it from the mean. That kind of gives me what's called my lower bound. Then I'm going to take my standard deviation and add it to my mean, and that's what's going to be called my upper bound. So I'm going to do a little I'm going to do x bar minus sx, which is 26.7 minus 9.1, and we'll get that in a second. And then x bar plus s sub x, that's going to be 26.7 plus 9.1. Okay, and let me just kind of exit out of this, grab my calculator really quick. I just don't want to do that by hand. Got to go over here, so I will do 26.7 minus 9.1, and that is 17.6. There's just no convenient way to put this, 17.6. And then let's do 26.7 plus 9.1, and that's 35.8. All right, so any value that is now between 17.6 and 35.8 will be closer than 9.1 units to the mean, so it will be within 1 standard deviation of the mean. Why don't you go ahead and do exactly the same thing for SOTA B? Pause the video now. All right, I think I can do this one without my calculator. All right, so I have x bar minus minus s sub x, which is 23.4 minus 4.1. That's going to be 19.3. And then x bar plus s sub x is going to be 23.4 plus 4.1, and that's going to be 27.5. All right, had to just barely squeeze those in there, but we got them. Now let's go back to here. All right, so again, everything within here, right, is within 1 standard deviation of the mean. Everything between here within 1 standard deviation of the mean. Now let's take a look at exercise number 6. The data sets are given again below. For each data set, circle all of the values that lie within 1 standard deviation of the mean. All right, so think about it, right? We're going to be for letter A, we're going to be circling all values from 18 up to 35, right? Because these are whole numbers, it's very easy. Anything between 18 and 35, including the 18 and the 35, we're going to circle, right? So for instance, I'm going to circle the 18, but not the 16, right? I'm going to circle the 22, but not the 16. Certainly the 28, the 18, the 21, right? Not the 38, it's too big, but the 22, the 29, 25, not the 44, it's too big, not the 36, it's too big, and the 27, right? So those values all lie between 17.6 and 35.8, so they all lie within 1 standard deviation of the mean. Pause the video now and see if you can do the same for SOTA B. All right, now think about this. I need all values between 19.3 and 27.5, so the smallest value I would circle would be 20, and the largest value I would circle would be 27. All right, so certainly 25 works, certainly 22 works, but 18 is too small, 30 is too large, 27 just gets in there, 19 is just barely too small though. 22 is in there, 28 is too large, 25 is in there, 19 again is too small, 23 gets in there, 29 is too large, 26 gets in there, 18 is too small, and 20 gets in there. Right? So there we have it, right? We've got these values in SOTA A that are within 1 standard deviation, and these in SOTA B that are within 1 standard deviation. Tongue-tied. Okay, exercise number 7. Find the percent of each data set that falls within 1 standard deviation of the mean. Round to the nearest whole percent. Well, keep in mind that what we have is we have 15 data points in each one of these, and in SOTA A, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of the 15 are within 1 standard deviation. And I'm going to do this the old-fashioned way. I'm just going to do 9/15 times 100. Very simple, right? So I'll just do 9 divided by 15, right? 0.6 times 100 would be 60%. So that's going to be 60% of all the data in SOTA A fell within 1 standard deviation. Remember, I said a little bit more than half of the data would fall within 1 standard deviation. Now, why don't you go ahead and do the same for SOTA B? All right, in SOTA B, it's only 8 out of the 15 that are within 1 standard deviation of the mean. That's not going to turn out quite so nice, but still not going to be too bad. 8 divided by 15, that's going to end up being 53% within 1 standard deviation of the mean. There we have it. All right, and again, all this is showing us is that roughly a little bit more than half of the data fall within 1 standard deviation of the mean, right? Very similar to the IQR, where 50% of the data fall within the IQR, right? I mean, pretty much exactly 50% of the data should fall within the IQR. Within the standard deviation, you should get a little bit more than 50%. And again, we'll try to quantify that a bit better in the next lesson, but for now, that's probably good enough. So, today we saw for the first time what's known as the standard deviation of a data set, which is yet another measurement for how much variation there is in a data set. And now we have 3 ways to measure the variation. The overall variation, measured by the range, the IQR, which measures the variation in the middle 50%, and the standard deviation, which roughly measures the average distance that a given data point is away from the mean. The standard deviation is an amazingly important metric or measurement in statistics. As long as you work in statistics, you will see the standard deviation. And eventually you may even see its ugly, ugly formula. Square roots, squaring, gross. It's just horrible. Anyway, point is, this is what we've got for now, and we're going to be calculating it on the calculator, and we're going to work with it a lot more in the next lesson. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.